Hi everyone, the purpose of this video is to go over the distribution of the sample proportion, which is the second of our distributions involving taking samples. In this case, we're talking about sample proportions. And if you look at these problems, they will always give you some kind of a sample proportion. For example, we start with a sample population proportion P. That's the true value of the population proportion. And we always have to have a sample of some size that's taken. Sample size is n. And the sample proportion is always calculated with this funny little notation p hat, which is equal to x over n. So it's the number of times something happens divided by the total. That is the same as the empirical probability that we calculated when we did the probability chapter back in chapter 5. Okay, so the parameters of the p hat distribution, so we're always talking about p hat. That's our distribution. It's our new variable. And we know that the mean is equal to whatever the population proportion is. And the standard deviation is given by this crazy formula right there, where we have to do the square root of the proportion from the population times 1 minus that proportion divided by n. And the last thing is whether or not it is normal. If it's normal, that condition has to be checked by making sure that this product is greater than or equal to 10. That's the same thing we used with binomial probability distributions to decide if the binomial distribution was normal or not, if it was bell-shaped. Okay, so these are the same three things that we always check. The mean, which is the center, the standard deviation, which is how widely dispersed the data distribution is, and then what's its shape, whether it's normal or not. Okay, so let's move on to the first question here, and we will use these formulas in this example. All right. So the first question says, in the United States, 69% of homes subscribe to at least one digital streaming service. Random samples of 160 samples are surveyed in different markets. Okay, so right there we know two things. We know that n equals 160 because we have a random sample of 160 households. We also know that the true population proportion is given as 69%. So P is equal to 69%. But we have to write that in decimal form. It's super important we write that in decimal form. If we don't, it's going to throw off all of our computations later on. Okay, so that's what we know. Part A says, if one sample had 124 households with streaming service, what is the sample proportion? Okay, so that 124, that's the x value. So when we write p hat equals x over n, we now know what that sample proportion is. It's 124 divided by the sample size, which was 160. And 124 divided by 160 is 0.775. So in other words, this particular sample had 77.5% of the people included, out of the 160, were subscribing to some digital streaming service. Okay, that's just one sample. That's all that was asked. What's the sample proportion? So part B asks for what is the mean, which is the center, the standard deviation, which is how widely dispersed it is, and whether or not it's normal. That's the shape. Those are these three things that I've highlighted right up here. That's how we describe the distribution. Okay, so the mean is equal to the proportion. So the mean of the new distribution is just equal to P, and that's equal to 0.69. The standard deviation, that's this dude right there, that needs some work. So the standard deviation for the p hat distribution is the square root of 0.69, that was p, times 1 minus 0.69 divided by the sample size, which was 160. Now all of this stuff goes under the square root. Some people get confused and they type in the square root symbol, but it's the square root of this whole entire group of stuff. So if you follow the order of operations, you would get the square root of 0.001336875, and I'm carrying all those decimals because I don't want to have a round off error. And then we take the square root, and that's equal to 0.036556. So that's the standard deviation, 0.0365556. And then the last question is whether or not it's normal. So to check if it's normal, that's where we check right here. Is that condition true or not? So if we put in n, that was 160 times p, which was 0.69, times 1 minus 0.69. We're checking to see, is that greater than or equal to 10? So when you multiply that out, it is 34.224, which is in fact greater than or equal to 10. So the answer is, yep, it's normal. It is normal. And that's great because that means we can use our app in order to find probabilities. Okay, so now we can use the properties of this distribution to find probability that a sample proportion is less than or greater than or between things. So we know that the mean was 0.69 and the standard deviation is 0.036556, and we know that it's normal. Yes, we knew it was normal. So I already drew the normal curves for part C and part D, and now we will try to figure out what that means. Part C asks us to find the probability that a random sample will have less than 70% streaming service. So first of all, we know it's less than, so we want the probability that the sample proportion is less than, and 70% we have to mark as a decimal, 0.70. Now, in order to get that, I'm going to mark 70% on the graph over here. It's something like that. That's about 0.70, just a little bit to the right of 69%. And we want less than, and less than means we're going to be shading the left side over here. Okay, in order to find that probability now, we're going to flip over to our app where I've already put in the mean and the standard deviation that we're going to need. The mean is 0.69, the standard deviation is 0.036556, and the probability that x equals 0.70, we use that for our p-hat, and the probability is 0.607786. So again, you could put this at 0.7, and it's the same thing. So we have the probability is 0.607786. So I go back to my note, and I will just write in 0.607786. And that is the probability that it's on the left. That's the area that's on the left side over there. For part D, we want to find the probability that a random sample will have at least 120 streaming service subscribers out of the 160. So the first step is I have to say, well, what is that p-hat? 120 out of 160 is equal to 0.75, or at least 75%. We want at least 120, which means we want at least 75%. That's the first step. Now we have to write that in probability. So the probability that the sample proportion is greater than 0.75, well, 0.75 is over here someplace. I don't know exactly where, but being greater than means I'm shading the right side. We're going to find that area right there. So if I flip back to our app and type in 0.75, change it to greater than, we get the probability is equal to 0.050366. Okay, same parameters, everything is the same. So go back to our note, and that is equal to 0.050366. If you wanted to round that to 4 places, which is the standard, you would write 0.05036 becomes a 4. Now further, someone could ask you, would that be unusual? And you would say, no, because it's a little bit more than a 5% chance, so that would not be unusual. I didn't ask that here, but it's just something you can throw in. All right, so keep in mind when you're talking about proportions, when you see proportions in the problem, it's kind of a giveaway. All right, please let me know if this helped. Thanks, and I'll see you soon. Bye.